Here we've written again our recipe for calculating the Haar measure. We've parameterized our group elements. Here the axes are the coordinates, and then we expanded this in the basis of the Lie algebra, and the coefficients here were used to define this weight function for the Haar measure. Now we want to do the crucial step in order to show left invariance. So we take our parameterization g of x and say this, if say x equals 0 is in the range of these x's here, then this is a parameterization in the neighborhood of g of 0. Now we multiply this with some group element h, and we get a parameterization in a neighborhood of, let's say, g tilde of x is h times g of x, and now we get a parameterization in a neighborhood of g tilde of 0, which is just h times g of 0. So what do we mean by this? If this is our group manifold, then maybe we've introduced some coordinate system here in a neighborhood of g of 0. And with this h, we can translate this somewhere else. So maybe we now have a coordinate system here in a neighborhood of g tilde of 0, which is just h times g of 0. And in order to check left invariance, we now calculate Haar measure in terms of this g tilde parameterization here. So we go through this procedure here again. What do we have to do? We write down g tilde of x inverse dg tilde of xj, dg tilde dxj of x. Now substitute this definition here. Then we have h times g of x inverse, and now only the g depends on x but not the h, so we can write h times dg dxj of x. But taking the inverse reverses the order, so we have g of x inverse h inverse h dg dxj of x. So the h's here go away, and we see that this is the same expression as this if we calculate the Haar measure here or here with this translated parameterization. So this means that d mu of g tilde, so that's d mu of hg, that's now the rho, let's say rho tilde, determined using this calculation here. So now we expand this in this basis of the Lie algebra. So we get a rho tilde of x dnx. But we could also have calculated d mu of g here, which is just rho of x dnx. But we see that the rho which we get over here is the same as the rho tilde we get from over here, because these two things are just the same. And by this we've established that d mu of, maybe here, d mu of hg is d mu of g with these special coordinate systems. So we've chosen a coordinate system here and one here, and of course we can repeat this with different patches and move and cover the whole manifold. And if we do an additional change of coordinates, if we want to use a different coordinate system here, we do step 1 again from the previous video, where we just make a local change of coordinates. So we can really independently introduce coordinates all over the manifold, do this calculation and see that doing this here, patch by patch, we don't change anything. So the thing is really left invariant.